Hello everyone, today we are going to start exercise 4.3. In this exercise, we will study about the nature of the roots and quadratic formula. So now, if ax square plus bx plus c equals to 0 is our quadratic equation, then value of x is given by minus b plus minus root b square minus 4ac upon 2a. Here, b square minus 4ac is the discriminant. Value of the discriminant will tell us about the nature of the root, that is whether real root exists or not. If discriminant is greater than 0, that is if discriminant is positive, then we are going to have two values of x, two distinct values. If discriminant is 0, then we are going to have two equal roots. If discriminant is 0, then we are going to have two equal roots, minus b upon 2a minus b upon 2a. If discriminant is less than 0, that is if discriminant is negative, then no real root will exist for that quadratic equation. First question, find the nature of the roots of the following quadratic equations. If the real roots exist, find them. First part, 2x square minus 3x plus 5 equals to 0. Now to find the nature of the root, we have to find discriminant. Firstly, a equals to 2. B equals to minus 3 and C equals to 5. So discriminant will become B square, that is minus 3 square minus 4, A equals to 2, C equals to 5. So minus 3 whole square equals to 9, minus as it is 4 to 8, 8, 5, 40. Now 9 minus 40 equals to minus 31. Here D equals to minus 31, that is negative. If discriminant is negative, then no real root will exist. So the nature of this quadratic equation is that no real root will exist. Second part, 3x square minus 4 root 3x plus 4 equals to 0. Here a equals to 3, b equals to minus 4 root 3 and c equals to 4. So discriminant equals to b square minus 4ac, that is minus 4 root 3 whole square minus 4 as it is, a into c, that is 3 into 4. Now minus 4 root 3 whole square equals to 48, because 4 root 3 into 4 root 3, 4 into 4 16, root 3 into root 3 equals to 3. So 16 into 3 equals to 48. Minus 1 whole square plus 48. 4 into 4 16, 16 3 48. Plus 48 minus 48 equals to 0. Here discriminant is 0, so two equal roots will exist. Now to find the value of x, we will use the quadratic formula, that is x equals to minus b plus minus root d upon 2a. D equals to b square minus 4ac. Here b equals to minus 4 root 3, minus as it is, b equals to minus 4 root 3 plus minus b square minus 4ac, b square minus 4ac equals to 0. So 0 upon 2a, a equals to 3. After solving, we will have minus minus plus 4 root 3 as it is plus minus 0 upon 6. Now on dividing 4 and 6 by 2, we will have 2 root 3 upon 3. 2, 2, 4, 2, 3, 6. So 2 root 3 upon 3, 2 root 3 upon 3 are the two values of x. Third part, 2x square minus 6x plus 3 equals to 0. Here a equals to 2, b equals to minus 6, c equals to 3. So discriminant equals to b square minus 4ac, b equals to minus 6, a equals to 2, c equals to 3. So after solving, we will have discriminant equals to 12, that is greater than 0. If discriminant is greater than 0, we will have two distinct real roots. So now to find the value of root, b equals to x equals to minus b plus minus root d upon 2a. b equals to minus 6 plus minus root d, d equals to 12 upon 2 into a equals to 2. So minus minus plus 6 as it is. Root 12 equals to find the factors of 12, use prime factorization method. 2 6 12, 2 3 6, 3 1 3. So 2 into 2 into 3. Root 12 equals to 2 into 2 into 3 root 2 will come outside and 3 remain in the root. So root 12 equals to 2 root 3 upon 2 into 2, 4. Now taking common from the 6 and 2, we will have 2 common. 2 into 3, 6 plus minus root 3 upon 4. Cancelling 2 by 4, we will have 2 here. Then 3 plus minus root 3 upon 2 are the two distinct values of the x. That is x equals to 3 plus root 3 upon 2 and 3 minus root 3 upon 2. Second question. Find the values of k for each of the following quadratic equations so that they have two equal roots. First part, 2x square plus kx plus 3 equals to 0. Now, for this quadratic equation to have equal roots, discriminant should be equals to 0. Here b equals to k. So k square minus 4, a equals to 2 and c equals to 3. Discriminant is 0 for the quadratic equation to have equal roots. K square minus 4 to 8, 8 3, 24 equals to 0. K square equals to 24 and k equals to plus minus root 24. So k equals to plus minus root 24. Second part, kx into x minus 2 plus 6 equals to 0. Now simplifying this equation, we will have k, x into x, x square minus k into 2, 2k, x being a variable as it is, plus 6 equals to 0. Now here a equals to k, b equals to minus 2k and c equals to 6. So discriminant is b square minus 4ac. For the equation to have equal roots, discriminant should be equal to 0. b square, that is minus 2k whole square, minus 4, a equals to k and c equals to 6. Minus 2 whole square, 4k square, minus 6 4, 24, k as it is equals to 0. From these two terms, we will have 4k common. After taking 4k, 4k square becomes k minus 6 4, 24, k common. Equating 4k equal to 0 and k minus 6 equals to 0, we will have k equals to 0 and k equals to 6. Here k equals to 0 is not possible because if k is 0, then the equation will not have the term x square and x. That is, after putting k equals to 0, we will get 6 equals to 0. So k equals to 0 is not possible. K equals to 6 is the only value for this equation. Third question. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square? If so, find its length and breadth. Let length of the mango rectangular grove be L and breadth of the mango rectangular grove be B. So according to question, it's given that length is twice its breadth and area, that is L into B, equals to 800 meters square. Now substituting this value of L in the second one, so we will get 2B into B equals to 800. 2 as it is, B into B becomes B square, 800 as it is. Now on dividing both sides by 2, we will have B square equals to 400. Now taking 400 to the left hand side, we will get B square minus 400 equals to 0. This is our quadratic equation in B, where A equals to 1, B is 0 and C equals to minus 400. Now discriminant equals to b square minus 4ac. After putting the value of a, b, c, we will have discriminant equals to 1600, that is greater than 0. So discriminant is greater than 0. It means two distinct values of x are possible. So x equals to minus b plus minus root d upon 2a. After putting the value of a, b and the discriminant, we will have x equals to 20. That is breadth is 20 meter. After putting the value of breadth in the equation number 1, we will have L equals to 2 into 20, that is 40 meter. So L is 40 and the B is 20. Fourth question, is the following situation possible? If so, determine their present ages. The sum of the ages of the two friends is 20 years. 4 years ago, the product of their ages in years was 48. That is, let x and y be the present ages of the two friends. According to question, the sum of the ages of the two friends is 20 and product of their ages 4 years ago is 48. So, to find a quadratic equation, find the value of y from the first equation and substitute it in the second equation. So, we will have x square minus 20x plus 112 equals to 0. This is our quadratic equation in x. Now to check whether the value of x exists or not, find the discriminant. D equals to b square minus 4ac. Here b equals to minus 20, a equals to 1 and c equals to 112. After solving, we will have d equals to minus 48, that is discriminant is less than 0. So no real root will exist. So it means that no such equations are possible. Question, is it possible to design a rectangular park of perimeter 80 meter and area 400 meter square? If so, find its length and breadth. So let L be the length and B be the breadth of the rectangular park. So perimeter is 2 into L plus B equals to 80. On dividing both sides by 2, we have L plus B equals to 40. L equals to 40 minus B. Area is given 400, that is LP equals to 400. Now substituting this value of L in this equation, we will have, after solving, b square minus 40b plus 400 equals to 0. This is our quadratic equation in B, where a equals to 1, b equals to minus 40 and c equals to 400. So discriminant equals to b square minus 4ac, b equals to minus 40 whole square minus 4, a equals to 1 and c equals to 400. Minus 40 whole square equals to 1600, minus as it is 4 into 1 4, 4 into 400 equals to 1600. So discriminant equals to 0. Discriminant equals to 0 implies that two real roots will exist for this equation, and the roots are given by formula minus b plus minus root d upon 2a. After putting the values of a, b and d, we will have 20, that is b equals to 20. Breadth is 20 meter. If b is 20, then L equals to 40 minus b, that is 40 minus 20 equals to 20 meter.